we have seen about the radius of atoms and ions, that is atomic radii, ionic radii, definition and also variation along the period and group. நம்ம ஏற்கனவே பார்த்திருக்கோம். Once again to revise and define, radius of an atom is defined as the distance of the outermost electron from the nucleus. Similarly, radius of ion is a charged species, is the distance of the outermost electron of the ion from the nucleus. Radius plural radii. So the radius of species, how it varies along the period and group. Once again to revise, along the group radius increases because additional shells are introduced along the group, whereas along the period no additional shell is introduced, additional electron goes to the same shell, and radius decreases with breaks. Now we will see the calculation of atomic and molecular radii. So radius of a molecule A and B is defined as the half of the distance between the nuclei of the A and B. Now if you consider an atom A and atom B, so the size of atom A R N சொல்லுவோம், size of atom or radius of atom B RB. So when they are in contact, so the distance between the centers is the twice the radius or half of the distance between the two atoms. For example, if you consider for the chlorine atom, so the radius of chlorine atom is defined as the half of the distance between the two chlorine nuclei or chlorine atoms. Adhe mari radius of hydrogen atom, idhe mari half of the distance between the atoms of hydrogen, that is in general radius of a homonuclear atom இருந்தாலும் heteronuclear atom இருந்தாலும் half of the distance between the nuclei of two atoms is given by atomic radii. For example, இப்போ கொடுத்திருக்கு, so the distance between two chlorine atoms is given as 1.98 angstrom. Angstrom ஏற்கனவே பார்த்திருக்கோம், 1.98 into 10 power minus 10 meter. So then radius of chlorine atom just by 2, 1.98 by 2.99 into 10 power minus 10 meter or 0.99 angstrom radius of. On the other, this is for homonuclear atom. If you consider for heteronuclear atom, so the distance between the two atoms is given as, for example, if you consider a molecule of hetero atoms A and B, two different atoms A and B, distance between them is defined as sum of the radius of atoms A and B. This also you can have. So this is for homonuclear molecules. For heteronuclear molecules, distance between the atomic nuclei equal to sum of the radius of the individual atoms. In this case, they will give any of the two parameters and you will be required to calculate the third. For example, distance of carbon chlorine linkage கொடுத்திருக்கு. Distance of carbon chlorine linkage is given as 1.76 angstrom. Radius of distance of chlorine linkage or carbon chlorine linkage for different atoms. For example, if you consider this type of compound, this is CHCl3, that is chloroform. Chloroform contains carbon chlorine linkage and this is given as the carbon chlorine linkage is given, and already we have found out the radius of chlorine atom. So from this you can calculate. So generally distance between the two atoms equal to sum of the radius of individual atoms, and if two parameters are given, third parameter can be calculated. This is the principle of determination of atomic radii for the heteronuclear molecules. For the homonuclear molecules, half of the distance between the two, that is to be noted. இப்போ நம்ம பார்த்தது வந்து radius of an atom equal to half of the distance between the two atoms னு ஜெனரலாக பார்த்துருக்கோம். இதில் வந்து the distance between the two atoms is also referred to as bond distance. So bond distance na distance between the two atoms. If the two atoms are same, it is exactly the half of the distance between the two atoms. Or bond distance, half of the bond distance is the radius of the particular atom. Whereas if you consider for two different atoms, in that case you got bond distance between the two atoms A and B equal to sum of the radii of A and B. So if bond distance and the radius of one of the atoms is known, the radius of other atom can be determined by algebraic sum. That is to be noted. So for the touching atoms, closest touching atoms, same atoms, the bond distance will be almost equal to the diameter of the system. That is why d by 2 equal to radius. So bond distance தான் இதை ரெஃபர் பண்ணியிருப்பாங்க. For similar atoms it resembles diameter, but for different atoms you cannot have this. For different atoms this has to be followed. That is bond distance equal to sum of the radii of the two different atoms. That is to be noted. These calculations are to be noted with respect to atomic radii calculation in a molecule. That is to be noted. So far we have seen about the atomic radii. Now we will see the radii of ions or ionic radii. For the simplest case, let us consider an ion AC. It is A plus C minus. இந்த மாதிரி ரெண்டு அயான் இருந்ததுன்னா the distance between the two ions, these are oppositely charged. A plus A deprived of an electron, A plus, and C, atom C gaining an electron, C minus. So they are oppositely charged, attracting each other. That is the bond distance is almost equal to the electrostatic forces. இந்த மாதிரி கேஸ்க்கு so radius of A plus is nothing but radius of the cation A plus radius of C minus, that is radius of the anion. Here general cation anion general கொடுத்திருக்கு, that is to be noted. C minus equal to, so representation எப்படி வேணா இருக்கும். You have to bear in mind that ions are charged species, cations are positively charged species, anions are negatively charged species. அவங்க இஷ்டத்துக்கு எது வேணா கொடுத்திருப்பாங்க. That is to be noted. This is not carbon generally ஞாபகம் வச்சுக்கோங்க. So equal to distance between the two ions, that is A plus C minus. இதுல ரெண்டு வேற வேற parameter, radius of positive ion, radius of negative ion, distance between the ions. So distance between the ions equal to sum of the radii of the respective ions. Ions are different. With regard to ions, ionic radii, these points to be noted. So generally size of the ion, that is nothing but radius, is proportional to size of the ion nalum radius nalum ஒண்ணுதான். It is governed by charge on the ion, governed by the charge on the ion. For example, let us consider for the three species of the same element, hydrogen plus, hydrogen minus. இப்போ ஹைட்ரஜன் சொன்னா 1 புரோட்டான் 1 எலக்ட்ரான் மட்டும் இருக்கும். ஹைட்ரஜன் பிளஸ்ல ஒரு புரோட்டான் மட்டும் தான் இருக்கும், நியூக்ளியஸ் மட்டும் தான் இருக்கும், எலக்ட்ரானே கிடையாது. ஆனா இதுக்கு ஒரு எலக்ட்ரான் உண்டு. H மைனஸ்ல ஒரு புரோட்டான் 2 எலக்ட்ரான் இருக்கும். இதே மாதிரி Cl க்கு கம்பேர் பண்ணோம்னா Cl minus, Cl சொன்னா atomic number is 17, that is totally 17 electrons are there. இங்க வந்து 18 electrons, Cl minusல 18 electron இருக்கும். Cl plus கூட இருக்கு, interhalogen compoundsல 15 electron இருக்கும். So இதுல வந்து generally radius of cation, that is positively charged ion, is less than that of radius of atom, which is less than ஏற்கனவே ஒரு தடவை பார்த்திருக்கோம். Once again to radius of anion. For the same species This is the radial distribution. Radius of cation is less than, or in other words, cation is of less size compared to the neutral atom. Neutral atom is of less size compared to the anion. Of the three species, anion will be having maximum size. So the size of the anion is maximum. Chloride anion, maximum size. Chlorine, minimum size. Similarly, protons are minimum size. Protons la only nucleus மட்டும் தான் இருக்கு, எலக்ட்ரானே இல்ல, first shell இல்ல. So distance of the outermost electron சொன்னா outermost electron இல்ல. So size is very minimum with respect to H plus. ஹைட்ரஜன்ல ஒரு டிஸ்டன்ஸ் இருக்கும். H minus the second electron அதே ஷெல்ல தான் போகுது. ஸ்லைட் இன்க்ரீஸ் வேணா இருக்கலாம், அது ஷெல் இன்க்ரீஸே இருக்காது. ஆனா குளோரினுக்கும் குளோரைடுக்கும் கம்பேர் பண்ணா குளோரின் வந்து chloride anion, size of the anion is higher than that of the atom. That is to be noted. இப்படி பார்க்கும்போது now we see the influence of charge on the ion. So charge on the ion plays a critical role on the size. Charge on the ion plays a critical, அதுக்கு வந்து generally in the formula to be noted. அதாவது radius of positive ion by radius of negative ion equal to the charge on the negative ion and charge on the positive ion. So this ratio, or in other words, radius of a particular ion is inversely proportional to the charge on the same ion. So this is to be noted. Radius of a particular ion is inversely proportional. அப்படினா என்ன அர்த்தம்? Rc plus is inversely proportional to Zc plus. Zc plus ங்கிறது charge on this ion C plus cation. So அப்ப நீ constant of proportionality introduce பண்ணீங்கன்னா equal to K by Zc plus. அதே மாதிரி Ra, so Ra இங்க denominatorல இருக்கு, so then Za goes to the numerator. If you compare the radius of the anion and cation, the radius of an ion is inversely related to the charge on the ion, charge on the same ion. That is to be noted. Here we have compared the radii of two different ions in terms of the charges. This is the general formula to be noted. So this if the nuclear charge is given, nuclear charge values are given, as well as radius of one of the ions is given, radius of other ion can be calculated. In general, this point to be noted. So qualitatively, radius of an ion is inversely related to the charge on the ion. Lastly, next we will see the aspect of what are called Slater rules. So Slater rules gives information why it is inversely related to the charge on the ion. Radius of an ion is inversely related to the charge on the ion because of a concept called screening effect. Screening effect. So next is the Slater rules, which gives information about the screening effect. That is to be noted.